And welcome to 19.5, where we're going to be talking about salts in solution. In this podcast, we're going to look at the acid-base properties of salt, and we're going to also look at a phenomenon called buffering. All right, so let's start off with a salt. And let's consider the acetate ion when you put that into water. So here's our acetate ion. When you put that into water, it's going to actually attract hydrogen away from the water. It's going to form its conjugate acid because, of course, the acetate, if it accepts the hydrogen, is the base. Water's behaving as an acid. The conjugate acid of the acetate is acetic acid, right here. And the conjugate base of the water would be the hydroxide ion. So notice what's happening. If you put in any salt that contains acetate, such as sodium acetate, potassium acetate, whatever the case may be, we'll just write down sodium acetate, then the amount of hydroxide would increase based on this reaction. Well, if the amount of hydroxide increases, then the solution will become more basic. And we'll do that in blue, just to be consistent here. So adding a salt that contains the acetate ion will make the solution more acidic. Now you can actually do the opposite as well. If you consider ammonium, the ammonium ion, which is right here. If you put that into water, it's going to act as an acid, and it's going to donate its hydrogen over to water, forming hydronium. And the conjugate base for ammonia, for ammonium is ammonia, which that 3 should be smaller, like so. There we go. So now, if you put any salt that contains ammonium, such as ammonium chloride, ammonium nitrate, then the amount of hydronium, which of course is usually just written as the hydrogen ion, is going to increase. Well, if you increase the amount of hydrogen that's in the water, or the amount of hydronium, then the solution becomes more acidic. So this salt, ammonium chloride, is an acidic salt. So here's the deal in terms of acid-base properties of salts. Salts that produce acidic solutions contain positive ions that release the hydrogen to the water. So therefore they're behaving as an acid, and therefore it makes the solution more acidic. On the flip side of that, salts that produce basic solutions contain negative ions, or anions, that attract the hydrogen from the water, therefore making hydroxides. Now, all salts contain positive ions and negative ions. It just depends on whether or not the positive ions can donate the hydrogen and whether or not the negative ions will attract the hydrogen. And that's not a topic that we're going to dive into too much, except for the fact that you should know that salts can have acid-base properties. All right? All right, moving on. Next page. Let's take a look at a phenomenon called buffering, buffers. You can actually make solutions using salts that will resist changes in acidity or changes in pH. Well, how would you do that? Well, you got to use a weak acid, or you have to use a weak base, one or the other, not both. And then here's the key, you have to use their conjugate salt. Now what does that mean? Well, let's take a look at this buffer where you have acetic acid, which is a weak acid. When you put that into water, it forms hydronium, and the acetate ion. All right. Now, what happens? Well, first of all, you have the acid. Okay, we'll go ahead and do that in red. So you have a lot here. If you add its conjugate salt, you're adding anything with this. This is the conjugate base, so anything that contains that in it, potassium acetate, sodium acetate, lithium acetate, whatever the case may be, you're going to be adding acetate ions. So now, in terms of equilibrium, you have a tremendous amount on this side. You have a tremendous amount on this side of the equilibrium. So what ends up happening is this. If you add a base, this will neutralize it. If you add an acid, this will neutralize it. And so therefore, if you add either an acid or a base, it's not going to change much in the pH. Let's try another one. Let's take, say, ammonia, or ammonia, yeah, we'll go with ammonia. And we'll put that into water. That's going to form ammonium and the hydroxide ion. So, here's the weak base. You add that. If you add any salt that contains the ammonium ion, now you have something on either side of the equilibrium, a significant amount. So if you add an acid, this base will neutralize it. If you add a base, this acid will neutralize it. So whether you add an acid or a base, you're going to be able to neutralize it to some extent. Alright? Now, what's going to happen if you add, say, some type of strong acid? If you add a strong acid like hydrochloric acid, when you put that into water, there's no equilibrium. It goes completely to this. So what's going to happen is if you add a base, if you add a base to this, it will neutralize this part of the equation. If you add an acid to it, this isn't going to do anything to it. It's just going to become more acidic. It's just going to keep going to the right. Unless you have an equilibrium, you can't shift both ways. So this cannot resist a change in pH. On the other hand, if you add a strong base to water, what happens? Well, there's really no net reaction here, because if this takes on the hydrogen, you're just going to form more water, and the water will become the hydroxide, so there's really no net change there. Alright, so once again, if you add an acid, yeah, it'll react with that. If you add a base, it's simply going to push this thing way over to the right there. There's no equilibrium to adjust. Now, the amount of buffering that example number 1 and example number 2 can give you depends on how much of your weak acid and your conjugate salt that you're adding. And the amount of buffering that can occur is simply called the buffer capacity. Buffer capacity. Here's the deal. If you have a tremendous amount of acid and conjugate salt, it can neutralize quite a bit of acid or base. On the other hand, if you barely have any weak acid and barely any weak conjugate salt, well, then you're not going to be able to neutralize very much because they will be used up. Alright, and we're going to demonstrate that in class or in a future video, and we'll be taking a look at that in the buffers demonstration down below. Alright, so salts can have acid-base properties, and a combination of a weak acid and its conjugate salt or a weak base and its conjugate salt will produce a buffer solution that resists the change in pH. That concludes 19-5 and all of Chapter 19.